Lesson 3, March 22nd through the 26th. Make sure you have Lesson 3 out. Estimating centers and interpreting the mean as a balance point. So we're going to estimate the mean and the median of the distribution. We're going to figure out if the mean is a reasonable description or is the median a better description. We're going to interpret the mean as a balance point, and we're going to indicate that the distribution in which neither the mean nor the median is a good description of a typical value. Alright, so let's go ahead and look at example number 1. Example number 1 states this. Your previous work in mathematics involved estimating a balance point of a data distribution. Let's review what we learned about the balance point of a distribution. A 12-inch ruler has several quarters taped to positions along the ruler. The broad side of the pencil is placed underneath the ruler to determine an approximate balance point of the ruler within the quarters. Alright, so we're going to look at this. It says, consider the following example of quarters taped to a lightweight ruler. Alright, so there is a quarter taped at 1 inch, a quarter taped at 9 inches, and a quarter taped at 11 inches. How do you think the quarters located at the 1 inch position affects the balance point? If that quarter were moved to the position of 3 inches, what would happen to the balance point? Well, think about this. Do you really think that the quarter at 1 inch is going to do much? Probably not, because I have 2 over here. But if I moved it to the 3 inches, what would happen? I think that the balance point would shift to the right in order to balance the sum of the differences. Alright, so let's look at this. He says Sam taped 3 quarters to his ruler. The quarters were taped at the position 1 inch, 9 inches, and 11 inches. If the pencil was placed under the position 5 inches, do you think the ruler would balance? Why or why not? Alright, so if I place the pencil here at the 5, do you think it would balance? I don't think that it would balance. So 5 would not be a position of balance. I think that the quarters at 9 and 11 would pull the balance toward that side. If the ruler did not balance, would you move the pencil to the left or to the right of 5 inches to balance the ruler? Explain your answer. Well, let's think about this. If I'm going to move my pencil this way, what's going to happen? Those two quarters are still going to balance down. So I'm going to have to move my pencil to the right. To the right of 5, because there's 2 quarters on that side. Alright, so I'm going to have to pull to the right. So it says, estimate the balance point for the ruler. Complete the following based on the position you selected. Okay, so the position of quarter 1. Alright. Distance from quarter to your estimate of the balance point. Alright, so where do we think we're going to balance this? Do we think maybe if we move it to 6, that might work? Alright, so let's see. If we we're going to say we're going to put the balance at 6 inches. Alright? So the quarter in position number 1 is 5 inches from the balance point. Alright, the quarter at 9 inches is 3 inches from the balance point. And the quarter at the 11 inch is 5 inches from the balance point. What is the sum of the distances to the right of your estimate on the balance point? Alright, so if we use the balance of 6 inches, which is what we're doing, then the estimate of my balance to the right is 8. 5 plus 3 is 8. Alright? What is the sum of the distance to the left of your estimate of the balance point? So the sum to the left there's only one to the left, is 5. Do you need to adjust the position of your balance point? If yes, explain. Using the balance point of 6, I would need to adjust because I've got 8 inches here and 5 inches here. So I would need to adjust. So if I'm using a balance point of 6 inches, I would need to adjust. Explain how? Well, I would increase the distance to the left and decrease the distance from the right. Calculate the mean and the median of the position of the quarters. Does the mean or the median of the positions provide a better estimate of the balance point for the position of the 3/4 taped to the ruler? Explain why you made this decision. Alright, so the mean of the positions, so how would I calculate the mean? Well, the mean, I would add, alright, oh, sorry, wait a minute. I'm not going to add the distance they are from my balance point. I'm going to add where they are. Okay, so they're at 1 plus 9 plus 11. So that's 21. I'm going to do 21 divided by 3, which is 7. So my mean is 7. How do I find the median? Well, I'm going to order them from least to greatest. And then I will start canceling out one by one on each side, get to the middle, and I find my median is 9. So the mean is 7, and the median is 9. Which one provides a better estimate of the balance? Well, let's think about this. If I put it on 9, that is a position of one of my quarters. It's probably going to be too far. I don't need to adjust a whole lot. So my mean is probably a better estimate of the balance point. So the mean is probably a better estimate of the balance point. If the mean position of 7 was selected, then the distance of the quarter to the left of 7 would be 6, and the sum of the distance of the 2 quarters to the right of 7 would be 6. So the balance point is would be 7. All right. All right, let's move on. 22 students from junior class and 26 students from the senior class at River City High School participated in a walkathon to raise money for the school's band. Dot plots indicating the distances in miles students from each class walked are as follows. The first one is the distance walked in miles by the juniors. The second one is the distance walked in miles by the seniors. All right, so it says estimate the mean number of miles walked by a junior and mark it with an X on the junior class dot plot. How did you estimate the position? Well, guys, if you look at this, it just says estimate. All right, we are estimating the mean. If you will notice, we're kind of skewed. We have some skewed data. All right. You can make a guess. I see higher numbers here. So I'm going to say that I'm going to estimate at 8. Alright, so I'm going to mark an X here. Alright, now guys, remember, this is just an estimate. Alright. So it says, what is the median of the junior data distribution? Well, I can find the median, and I can just go up here and start marking off dots. So there's 1, 1, there's 2, 2, 2, 1, 1, 1. So it's between 8 and 9. All right. So 8 plus 9 is 17. 17 divided by 2 is 8.5. So my median is 8.5. Alright. Is the mean number of miles walked by the juniors less than, approximately equal to, or greater than the median number of miles? If they're different, explain why. If they are approximately the same, explain why. Well, my estimate is less. Alright? It is less than the median. The small cluster of data values to the left pulls my mean in that direction. How would you describe the typical number of miles walked by a junior in this walkathon? The mean appears to underestimate the distance walked by a junior. Only 8 students walked less than the mean. If I were to actually find the mean, alright, I would see that only 8 students walked less than the mean. Alright. While 14 students walked more. So in this case, the median is a better description of the typical data. Now we're going to look at the seniors. Estimate the mean number of miles walked by a senior and mark it with an X on the senior dot plot. How did you estimate this position? Alright, so let's look at my senior data. Alright, the distribution seems to be symmetric, around 6 or 7. Alright, the balance point should be in the middle of that distribution. So I'm probably going to mark my mean right here. All right. I'm going to mark it about 6.5. Because the data is symmetric. What is the median of the senior class distribution? Once again, I can go back over here and I can just start looking at 1, 1, 1, 1. There's 4, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3. So it is 7 and 7 are my two dots. So the median is 7. All right. Estimate the mean and the median of the miles walked by the students. Is your estimate of the mean number of miles less than, approximately equal to, or greater than the median number of miles walked by a senior? If they're different, explain why. If they're approximately the same, explain why. Alright, so a typical number of miles walked by a senior would be right around 7 miles. We figured out that our mean and our median were close. Okay. How would you describe the typical number of miles walked by a senior in this walkathon? Okay. That should go down here. Here we need to say that they're about the same. Okay, so this one should go down here. The typical number of miles walked would be about 7. All right, and here this would be they're about the same. A junior from River City High School indicated that the number of miles walked by a typical junior was better than the number of miles walked by a typical senior. Do you agree and explain? Well, we figured out that the median of senior data is 7. The median of the junior data was 8.5. So yes, the median is a better indicator of typical value for the junior class. So the median for juniors was higher than the senior class. Okay? So the median for the juniors was higher than the senior class. Finally, the 25 sophomores who participated in the walkathon reported their results. A dot plot is shown below. What is different about the sophomore data distribution compared to the data distribution for juniors and seniors? Well, in this case, it's a U-shaped. I've got a bunch of data down here, and I've got a bunch of data up here. Okay, it's U-shaped. Estimate the balance point of the sophomore data. Well, I can estimate the mean of it to be, so if I've got 2, 4, 6, 8, 10, 12, 13, 4, 6, 8, 10, 12. So I'm right about the same. Guys, I'm going to go to the middle here. So I'd say that it's right about 5 as my balance point. What is the median number of miles walked by a sophomore? All right, so there's 25 values. So I've got 2, 4, 6, 8, 2, 4, 6, 7, 8, 1, 2, 1, 2, 2, 1, 2. So it would be 2. The median is 2. How would you describe the sophomore data distribution? It's U-shaped. The values are either small or they're large. There's no in between. I can see that. They're either small or they're large. And in this case, the mean nor the median, so the median is 2 and the mean was 5. The mean nor the median are good indicators here. Alright, so it's not a good indicator of the typical sophomore. Alright, that is the end of lesson 3.